Hello guys and girls, welcome to the computing workshop. I am the mad computer scientist and this is my workshop. Today we're going to start a multi-part series, small series, covering, we've been doing some vintage stuff lately and we did some experiments in Pascal and whatnot. Now we're going to discuss some current generation software development and software architecture that is interesting and getting a bit of a sparked interest again, and that is the Go programming language. That is with the announcement from AWS that Go is now a full class citizen on the AWS infrastructure. You could run Go programs in serverless environments and so on, and really put AWS to use for distributed computing using Go. Also, the Go has been updated since its inception and has gathered a bit of a momentum again because for several reasons, but mostly because it's a very good programming language to design distributed networked systems, and that goes hand in hand with the very much of a buzzword right now, which is microservices. You probably heard this if you work in the IT, the software industry. You heard of this most likely, and so we decided we would do a series on a mini series on the Go programming language, where we study the language and the basics of the programming language to get up to speed on that, and we also study the software architecture behind this microservice buzzword, what it really is, and how we can use the Go programming language to build a microservice and call it from externally. So to get started, the Go programming language is, like I said, we will start with that. We will start with the Go programming language. First of all, in this first part, we will look at installing and testing our Go installation on a Windows machine. This is a Windows 10 machine, as you can see. You can the Go programming language is, like I said, a statically typed programming language that compiles to a binary. It was designed at Google by Robert Griesemer, pronunciation Griesemer. If I mangled that name, sorry, Rob. Rob Pike and Ken Thompson. So you may know of Ken Thompson as the father of Unix, if you like, and actually he created Unix together with, among others, AT&T or Bell Labs veteran Rob Pike, which is also a co-creator of the Go programming language, as is Ken Thompson. It was designed in 2007 at Google, and it's meant to be efficient, and it's meant to be readable, and it's meant to be highly performant when it comes to predominantly to multi-threading or multi-processing, in which it employs a CSP style model. It means it employs a messaging based concurrency model, where separate threads or execution pipelines can use channels to communicate with each other and synchronize, while working together in parallel to process large problems, which is ideal for the type of microservices distributed computing patterns that are emerging now, which is why Go is seeing a resurgence in popularity. So Golang has its home, as we mentioned, on golang.org, where you can download the requirement, the required tool chain, including the compiler and the command line tools. It has a command line compiler, so you need to get started. You need basically three things on a Windows computer. You need Go itself, which you can download from golang.org. You need to have Git, because Golang is very much tied to. Note that I am using Golang and Go interchangeably here, because Golang is the way to speak of the language when you search, because you Golang, the Golang name came from, I mean, if you search in a search engine from Go, you're gonna get a lot of results. So basically, you normally use Golang to express the Go programming language. Okay, which is why this is also golang.org. So you need Git. It's very much tied to Git because you can have direct, for instance, GitHub integration in the language itself. I will show this later on. You can have it's very much dependent on Git and on GitHub. So you need that. You also need this to be able to install some of the stuff that you will need for your editor, because you also need an editor, because Go is delivered as a command line. The binary distribution is the command line tools, including the compiler. So to write the source code, you need a good editor, and for that, on a Windows machine, I definitely recommend Visual Studio Code. So Git, you need to get from git-scm.com. Install that. So first install Go, then install Git from this address, and then install Visual Studio Code from code.visualstudio.com. Microsoft actually created this editor as a free code editor. It's very scaled down as compared to like a larger IDE like Visual Studio. It's a pure back to basics editor with all the kinds of features you may need in an editor, with also excellent Microsoft Visual Studio parts like the IntelliSense syntax suggestions and things like that. So download and install that one as well. Now that you have these three things installed, which I already have on my machine, we can then write a small test program, perhaps, just to check out your installation. So now I am going to assume that you have installed these three tools, the Go toolchain, the Visual Studio Code editor, and Git. So now that you have these, you can start Visual Studio Code, and not doing that. Go as a programming language is a bit sensitive with what it calls the workspace. I'll show you. If I go to my user folder, which would be here, maybe, let's go. So if I go to this user folder, you see I have a folder here that I've created in this is my workspace. So Go points out to a specific workspace area where it wants you to have, yeah, it wants you to have the binaries, and it wants you to have your source code here. And I've under the, so if you don't have this path after installation, like your users folder and then your machine username, and then you create a folder called Go, and then you create two folders, bin and src. Src is where the source code goes, and bin is where compiled binaries go. This is something that is set up on the installation of Go. It sets an environment variable that points to your workspace directory, and it's a bit picky with how you structure things in this directory, because it has tooling that it wants you to structure things in a specific way. So it wants you to keep your source code here in src in subfolders, and it wants you to build programs in the bin binary folder normally. So I've just opened this folder in the editor, so you can in Visual Studio Code you can open a folder. So this is like your root, and this is the src folder we were just looking at. Here we can see I created a folder in there called hello, because that's also a thing. It wants you to have, if you have a source file named like hello.go, it wants this program source to reside in /src/hello. And this Go has a bit of peculiarities like that. Another thing is if you import something, like you import a library and you want Go to use, you don't use it, so you don't end up using that library. But you have in Java or C# or something like that, you can have import statements. It doesn't really matter, but in Go that actually gives you an error if you have unused imports, for instance, or if you have variables that are not assigned to, or something like that. So that it actually it's quite a strict it follows a certain pattern which you eventually get used to, and it tries to, the reason is that it tries to make you avoid making mistakes and having unstructured code. So in this hello folder I'm going to create, so I created this folder now under src, so I can see, and here I will create under this one I will create a new file. First of all, let me show you the extensions. If you click this button in Visual Studio Code, I've already installed this. If you search for Go, you will find a package called Rich Go Language Support. You would definitely want to install this, because this gives you the syntax highlighting, the linting, the linting. It will check your source code after you save, for instance, for any discrepancies or issues. It's going to give you debugging capabilities, a lot of really nice tools for Visual Studio Code when writing Go code is in this package, and it's a combined package of several tools. You also need to have Git installed to install this, which is also one of the reasons you want to install Git before doing this. And then you just select install. I already have it installed, but you select install, then you restart, and then the first time you create a Go source file, it's going to want to install other stuff, and then you just tell it here that you want it to install all, because it's going to place this here, that it wants to install additional stuff, and just let it install it and restart Visual Studio Code, and you should be good to go. Now that we have that here, we go back to the Project Explorer. In Hello, let's just give our first taste of programming in Go in this environment, writing the most classic of programs, the Hello World programs. We select a new file in this folder and we write hello.go maybe. Okay, so let's write some code then for small hello world example, which will also show you some of the basics of the language. So we'll start by declaring a package. I don't want to call it hello. We need to call it main. What the hell? Here you see the IntelliSense in action, by the way. But we want to call the package main. You can also add a semicolon after certain statements, but it's not necessary in Go. It's optional, and the linter in this case will actually remove them if you do. And we can write package main because we need a main package under our source hello src/hello folder, because that's the entry point of the application, and this should contain then a function called main, just like in C, for instance, where this is the entry point of your program. Now packages are units. We can also include, we can import other units, which we will do in this case. So we will import something called FMT, which is a standard library for formatted output, input, or input for that matter. We can now we can use this, and now you will see the IntelliSense in action. So you will have IntelliSense will give you suggestions. So we can see that there is a function in FMT that is named println or println. We use that one, and we type hello world and 3 exclamation marks, because that's really hello. So now we save it, and it's linted OK. So everything seems fine. So already here you can see some of the basis of Go. You can see that there are things called packages, which are units of compilation, just like the same as in C and Java and so on. You can import these in like Java, or the using statement in C# and so on. These are, call them what you want, assemblies, packages, units, whatever. By the way, I'm going to assume that you have some sort of programming background, because I'm not going to teach you programming in general. We will go over Go and very briefly in the basics of Go and the Go programming language, but you will need to have some insight into general programming terminology, be it from C or C++ or Java or C# or even Pascal or whatever, will be fine. And then you can see there's something, the equivalent of a C function, which is the keyword is func, and this is the main function, and this is the entry point of the program, like in C as well. And then that you can use parts or functions in other units that you have imported by using the dot operator to access things in this, yeah, as I said, call it unit or namespace or package or whatever. And you can also write, of course, write your own and group functions together. Note that Go is not it's not an object-oriented language. It's a structured language like C, but it's not an object-oriented language. So you don't actually instantiate objects like C. It supports data structures, or records, but it doesn't support the the class-based object-oriented patterns of C++ and the languages that followed on that, like Java and C Sharp. So these are functions. However, it supports interfaces, but in its own special way, which we will also look at probably in a later part. So now that we have this small hello world example, let's see if we can make it run as well. So we will issue in the terminal, we will issue go build. So at the bottom of the Visual Studio Code editor, you have these, you can check for output and so on. You have the terminal tab where you have in my case is CMD terminal. You can add other types of terminals here if you want. CMD is the one to use, which is standard command line. So now we can do go build, and this will actually, if we type this, this will invoke the compiler on the source in this specific folder. So that's not going to work there because we're going to have to go into our hello folder here. So here we can issue go build. Yep, and now it built something called hello.exe, and this is the executable file. So we type that. Yep. Okay, so everything is working fine, and that's that for part 1 for setup and toolchain installation.